In section 11 of chapter 1, we're going to be solving 3 by 3 matrices. Now the only thing difference between a 3 by 3 and a 2 by 2 is the 3 by 3 we have an x, a y, and now a z. So there's 3 variables. If there's 3 variables, you're going to need 3 equations. That's why we have 3 equations. Now before I even really show you how to do this, I want to explain what it is we're trying to find. What we're ultimately trying to find is a matrix where it goes something like this. 1, 2, 3, 4, and then something like 0, -2, 8, 16. I'm just making up these numbers. And then we get something like 0, 2, 0, and then like 4. Now the reason why this is desirable is because in this third row, we have 2 zeros, which means we have no x's, we have no z's in this case, we only have y's, and then the solution. So if I actually translated that into an equation, it would be 2y equals 4, which would then give me y is equal to 1. Once I know y, I could then use the other row that has a single 0, and I could get, well, there's 0x, but -2 times my y, which I just found out in my random example, is equal to 2, for some reason it just kind of cut out, is equal to 2, plus 8 times z is equal to 16. I could then solve for z. Once I know z, I can find x and z and plug it into this equation. So by getting 2 zeros in one row, and 1 0 in another row, and then one row with nothing but numbers, it'll allow us through a cascading effect to figure out what the remaining variables are. Now, it does not matter which row has the single 0 and which row has the second 0. Like another one that I could look for is something like this: 0, 0, 3, 9, and then like 4, 0, 2, 6, and then 1, 2, -3, 18. Again, you want a single row with 2 zeros, you want another row with 1 0, another row of just numbers. Now, by happenstance, by the fact of the technique we're about to employ, 2 of the zeros will always line up vertically. They'll either be right here, or they'll be here and here, but they'll always be on top of one another. And in the row with 2 zeros, one of them will be on a lonesome vertically. Alright, so let's do this, shall we? The first thing I'm going to do is I'm going to convert this into a matrix. There's a 1 in front of the x, a 2 in front of the y, a -5 in front of the z, and then a 7 all by its lonesome. And then for the second row, I've got a 2 in front of my x, I've got a 3 in front of the y, a 1 in front of the z, and then a 10 for the solution. And then for the third row, for the third equation, we got 3x, -1y, -2z equals -7. Now the only thing we can do to accomplish the goal that we want is I can take an entire row and multiply it by a number, or I can take 2 rows, like the first and the second, or the first and the third, or the second and the third, and I can add them together to replace one of those 2 rows. Now what we want to do is we want to get a single column to have all the same number, but one of them be negative. So I could turn all of these into a 6, but one of them would need to be negative. I could turn all these into a 6, or I could turn all these into a 10. Now I'm not going to really do this one just because 10 is bigger than these 2, which would turn into 6. So really I'm just going to pick which of these 2 I want to turn to 6s. I'm going to pick the second column purely because I already have a negative and 2 positives. So the first thing I'm going to do is I'm going to take row 1 and I'm going to multiply it by 3 because that'll get me a 6 right here. Then I'm going to take row 2 and multiply it by 2 because that'll get me a 6 here. And then I'm going to take row 3 and I'm going to multiply it by 6. And this is going to give me a new 3 by 3 matrix. The first row, when I multiply it by 3, I'm going to get 3, then 6, then -15. And I got to do my vertical line to separate it from my solutions. 7 times 3 is 21. Next, I'm going to take the blue row, the second row, and I said I was going to multiply it by 2. 2 times 2 is 4, 3 times 2 is 6, 1 times 2 is 2, 10 times 2 is 20. And then finally, I'm going to multiply the third row by 6. That's going to give me 18, That's going to give me negative 6, it's going to give me negative 12, and then it's going to get me 6 times 7 is negative 42. So now I have one column that all have the same number and one of them is negative. What that's going to allow me to do is I'm going to pick two of the rows to add together, such that the middle column will zero out. So I would take row 1 and replace it with row 1 plus row 3, because if I take row 1 and add row 3 to it, these two in the second column would cancel and give me a 0, which again is what I'm trying to get. So the red 3 and the green 18 are going to combine together through addition to get me 21. The red 6 and the green negative 6 from the third row are going to combine to get me a 0. The red 15 and the green negative 12 is going to get me a negative 27 vertical line. And then the red 21 for the solution and the negative 42 is going to give me a negative 21. And I'm already dreading the next step I'm going to do after this. Alright, next I'm going to take the second row and I'm going to replace it with row 2 plus row 3. I'm doing that because the blue 6 and the green 6, the blue 6 being from the second row, the green 6 being from the third row, those two will also zero out, so I'll get another 0. The blue 4 and the green 18 is going to get me a 22. The blue 6 and the green negative 6 is going to get me 0, which is what I wanted. And the blue 2 and the negative 12 in green is going to get me negative 10. And then lastly, the blue 20 and the green negative 42 is going to get me negative 22. Now the third row, I'm not going to touch at all. I already got my zeros that are stacked on top of each other. The green row I'm going to leave alone. In fact, I'm not going to touch it for most of the rest of the equation. And now I've got to repeat this process, and this is where the problem that I picked, the numbers are not so nice, because I either have to turn these two numbers into the same, or I have to turn these two numbers into the same value. Technically, it does not matter which. I am going to turn the 21 and the 22 into the same number, so I am going to take the first row and multiply it by 22. Then I'm going to take the second row and multiply it by negative 21. Now the reason I'm doing negative 21 is because I want one of these to be positive, one to be negative. Since they're both positive, I need to multiply one of them by negative. Alright, I need to pull out my calculator because I'm not smart enough or fast enough to do this off the top of my head. 21 times 22 is equal to 462. 0 times 22 is 0, and then 27 times 22 is equal to 594. Negative. Then I have a 21 times 22, which I already did, is 462, and it will also be negative. Now it's time for the blue equation. 22 times 20, negative 21 is going to be negative 462. Then we're going to get a 0, and then that's going to turn into a positive 210, and then that'll give me a positive 462. And the green row we're just copying and pasting. 18, negative 6, negative 12, negative 42. Alright, believe it or not, we are nearly there. We actually have one more matrix operation to do, which is we're going to replace row 1, but we could also replace row 2 with row 1 plus row 2. Because now that I have these as opposites, when I add them together, they will eliminate. So 462 in red plus the negative 462 in blue gives me 0. 0 and 0 give me 0. Negative 594 and positive 210 is equal to 384. And then negative 462 and positive 462 gives me 0, which is going to be really nice because it's going to get rid of that really, really ugly, disgusting number that we got earlier. 210, 462, 18, negative 6, negative 12, negative 42. And now we actually have accomplished what we wanted. We have a single row with 2 zeros, a single row with 1 0, and a single row with nothing but numbers. So we can use that top row we're going to have 384z is equal to 0. You would divide both sides by 384. And we would get that z is equal to 0. Once we get the value of our first variable, we are 95% done. The rest of the work is just plugging in and finding the other variables. Now, if I wanted to, I could take that value for z and plug it into this blue row as an equation. And that would work. That would work just fine. Kind of scares me a little because the numbers are really, really, really big. But I can pick any equation that has a row with a single 0 in it. So I could also pick this one, which again is the same as the one I just got done circling. Or I could do this one. This one's got smaller numbers, so I might be more inclined to utilize that equation. So that equation would be 22x plus 0y minus 10 times z, which I just found out is equal to 0, is equal to negative 22. Negative 10 times 0 is nothing. Divide both sides by 22. And that'll allow us to get x is equal to negative 1. Now that we have our second variable, we could again plug that into this green row because we have x, y, and z defined. Or I could plug it into this row, or this row, or this row. It does not matter, or any of these three original equations. All of them will produce the same answer. It's just pick and choose at that point. I'm going to pick this row because we have kind of ignored the green row for a bit. So it's going to be 3 times my x value minus 1 times my y value, which we don't know, minus 2 times our z value, which we know is 0, equals negative 7. Negative 2 times 0 is nothing. 3 times negative 1 is negative 3, minus y is equal to negative 7. We could add 3 to both sides. That would get us negative y is equal to negative 4. Then we could multiply both sides by a negative 1 or divide both sides by a negative 1. It's the same thing. And that would give us, kind of have enough room, y is equal to negative 4. And do not leave your answer in this format. We are looking for a location where all three of these functions, if they were graphed in three-dimensional space, where they would intersect, and they would intersect at the coordinate 0, oops, not 0, my x value is negative 1, my y value is 4, and my z value is 0. This is the three-dimensional location where they intersect.